Welcome to Energy Frontier, the Wyoming Landscape podcast. Hosted by Dr. Holly Krutka, Executive Director of the School of Energy Resources at the University of Wyoming. The show highlights SER's role supporting our mission to promote energy-driven economic development for the state of Wyoming.
Welcome back, listeners. Today, we're going to speak with two experts on hyperspectral imaging. It's a technology that acquires and analyzes reflected light in different regions of the electromagnetic spectrum, often beyond what the human eye can see. And it's transforming how we understand the Earth's surface. And we're going to talk about the technology broadly, as well as potential applications to the state of Wyoming, and also what we're doing here at the University of Wyoming School of Energy Resources, and how researchers here are beginning to apply this technology to Wyoming's unique geology and energy resources. The two experts we're going to speak with today are James Amato. He is a researcher here at the School of Energy Resources, and Dr. Friederike Körting, a spectral geologist from Hyperspectral. And they're going to talk about how the technology works, why it matters, or why it could matter for Wyoming's economy and environment, and some of the opportunities it could create for students, communities, and industry. So, Freddie and James, thank you so much for being here. Let's start with your backgrounds. Just give a little background, tell our listeners who you are and where you came from. James, let's start with you.
Thanks for having me, Holly. My name is James Amato. I am an associate research professional and division manager here at the School of Energy Resources in the 3D Visualization Center. I oversee SER's GIS and remote sensing capabilities. I've got a strong background in field geology, GIS, and unmanned aerial systems.
Great. And Freddie, can you talk about your background?
Yeah, absolutely. Thanks for having me. So my name is Friederike Körting. I work for Hyperspectral as an application expert in geology. What we're doing at Hyperspectral is predominantly develop really high quality, scientific grade spectral cameras. And I'm using these cameras to apply them to different applications in mining, geology. We have a lot of different projects with different clients, but also with academia to figure out how these cameras can actually add value to processes that would characterize minerals or different materials.
Great. So let's start simple about the technology. So talk about just the basics. What is hyperspectral imaging in everyday terms, and how is it different from like a regular photograph, a thermal image, or even multispectral imaging, and also explain what that is too?
Sure. Let me start, and then James can catch up on what I'm dropping maybe. So hyperspectral imaging is very similar to RGB imaging, so which is what our eye is seeing or what cameras are actually capturing. So we're capturing a portion of the reflected light off a surface. And that can be represented in 3 different colors, in red, green, and blue. But it can also be represented in much longer wavelength ranges. So we can capture a lot more energy from that reflected spectrum than what a normal RGB camera would be doing. And this can be captured in just a couple of different very broad bands, which is then usually referred to as multispectral imaging. Multispectral imaging captures the reflected radiation that we get from a surface in a couple of really broad bands. And you might have seen that in imagery from NASA or from other satellite platforms, where we are not only using that to get a really sharp image of the Earth's surface, but we're also using that to predict different characteristics of the Earth's surface. And that could be soil quality, or it could be changes in like water quality in lakes and something like that. So that's the main difference between our RGB camera and a multispectral image. And when we're talking about hyperspectral, we don't only capture the reflected radiation in a couple of broad bands, but we're capturing it in 100 of different bands.
Wow.
And it gives us a lot more information on different minerals. It gives us information on chemical changes within those minerals. And in some cases, it even gives us element proportions.
Wow. Anything you want to add?
Sure, yeah. So I think in the simplest terms to describe the difference between RGB, multispectral, and hyperspectral imaging, we can compare it to boxes of crayons. RGB, red, blue, green, there's 3 bands. It's kind of like that 3-pack of crayons that you got at Denny's or Perkins as a kid.
Totally.
To sit there and color. Those 3 colors we can blend together, and that's visual light. That's what most cameras on our smartphones have. When we talk about multispectral imaging, it's kind of like a 10-pack of crayons. You have 10 crayons, and they're all very distinct colors. So you get a little bit more out of it from RGB, but you're still somewhat limited. And hyperspectral imaging is that 120 pack of crayons that our parents never bought us, right? But with 120 different crayons, there's a lot of shades and tones, and a lot of those colors are very similar to each other. So it really just allows us more room to see things in different regions of the electromagnetic spectrum.
Great. And only one correction. I do buy those. And as soon as they get in the house, there's like 3 missing instantly. So, but that doesn't happen here. So, James, can you talk about where these images come from? Satellites, airplanes, drones, field lab. Like, why would a researcher choose one platform or another?
Sure. So hyperspectral imaging was a technology developed by NASA in the 1980s. And it was often found on satellites. Mm-hmm. These are cameras put on satellites that are, rotate around our planet, go out into the solar system, and they're used basically to identify materials on planets, right? And so over the years, the technology has gotten better, and these cameras can now be put on manned aircrafts. In recent years, the technology has gotten even better so that we can actually put them on drones. Mm-hmm. So all this, whether it's satellite, manned aircraft, or drones, it's really used for surface mapping, and they're used at different scales. So the farther away we are from the Earth, if we have a camera, let's say on a satellite, it can cover a significant greater area, right? But it also has an effect on the resolution. It's a coarser resolution, should I say. Where manned aircraft, you are closer to the Earth, you can still cover significant differences, and that increases the resolution. And if we're putting it on a drone, we're covering less area, but we're getting a finer resolution. So it really just depends on your application. If you're trying to cover large distances, satellite might be your best option, but again, you're going to get a little less in the spectral resolution that you would if you were flying closer to the Earth on a drone. As far as field applications and laboratory applications, sometimes you can put hyperspectral cameras on tripods. And maybe if we were in a coal mine right now, there might be a high wall or a vertical exposure. And traditional methods using satellite or airborne hyperspectral imaging, it's very hard to capture those vertical exposures. So putting it on a tripod allows us to capture those. You could even think of like a road cut exposure if you were driving along the highway. And then additionally, these cameras can also be used in the laboratory. We can take them and we can, hyperspectral imaging is a technology that allows you to identify surface materials. So it can't penetrate into the ground, but we can take drill core and hand samples that we extract from the ground and then scan those in the laboratory to get a feel for the mineralogy.
Oh, cool. And you've already made that transition. So obviously, this has huge applications in the area of economic and environmental geology. So Freddie, can you talk about what advantages does this technology offer compared to traditional geologic mapping or sampling? And maybe how do those fit together?
Yeah, absolutely. So for the advantages of the technology, as James already said, we do get an image of an outcrop or of a larger area, and each pixel in that image will represent the material characteristic of that pixel. And if we're talking about UAV images, for example, or drone-based imaging, we're getting information about 6 to 10 centimeter pixels.
Okay.
Which is compared to satellite images. There's some hyperspectral satellites out there right now that capture at around 30 or 20 meter pixels.
Okay.
So you get a lot higher information, lot more information in the spatial resolution, but you're also getting the material characteristics of a really finely resolved image. If we compare that to traditional methods where we have more sparse sampling and also much longer processing times, we're actually enabling people or people in mining or in exploration to get more information in a faster time frame. All of that complements the traditional methods, so it's not necessarily replacing them, but it gives us much better ideas on where to sample, to have more precise drilling campaigns, and maybe also save money on going into the field and doing a more precise field planning.
So how early in the exploration process can hyperspectral imaging add value? And is it useful before drilling begins, or maybe only after a target has been identified?
Hyperspectral imaging has been adding value to exploration from the start, and that's what has been used for the last at least 2 decades.
Okay.
We didn't have a lot of hyperspectral satellites out there. The last couple of platforms just came online in like the last 5-ish years. But before that, we used multispectral imaging, and that's just an approximation of that same signal. And you can use that even before drilling starts. As I said before, you would use these kind of data sets to map out changes in the mineral surface of really large areas. In the case for porphyry copper, especially copper mining, you have these really, really big alteration halos. And in order to find where copper mineralized and where you would want to drill to figure out the subsurface composition of that deposit or modeling for that deposit, before you actually do go into your drilling campaigns, you can use the data to identify areas that are spectrally homogeneous or spectrally interesting and point you toward areas where you would want to set up drilling. And that can reduce drilling cost by avoiding drilling into barren ground, for example.
Sure. Yeah. And so how does the hyperspectral image, like, how does it see materials differently than what we could do with the human eye or a standard camera?
Yeah, so since we are working with the reflected portion of energy from one mineral, for example, this mineral has a very specific chemistry and molecular composition. The different molecules in that crystalline structure of the mineral, they will get a portion of that incoming energy, and they will be excited by that in different forms. And that excitation of different bonds, for example, in that mineral, it actually costs some of the energy that will not come back out and be reflected back into our detector or into our camera. And all of that is wavelengths specific. So in specific wavelengths of that electromagnetic spectrum that we're capturing back from our image or from our material, we'll see very clear differences in where it absorbed some of that energy. And that is mineral specific or element or molecule specific. Mm-hmm. Yeah. So we actually see something like a fingerprint or like a barcode for each different material, which means that we get a spectrum back from one specific pixel, let's say the 6 centimeter pixel from our drone-based platform, and we can say that there is a halo of alteration that is 10 meters wide that has one very specific mineral that points us to where copper would mineralize together with that mineral.
And so let's talk about where this is being used, and then we'll transition into kind of focusing on applications for Wyoming. So, Freddie, which countries are leading the way in hyperspectral imaging for mining or energy development, and where is the U.S. as a whole in terms of adopting this technology?
That's a very good question. We were just at a meeting together in Colorado School of Mines because there is a bigger community now on hyperspectral imaging in mining, specifically in core scanning. The technology has been adapted quite widely for core scanning, both for drill chips and also for diamond drill core. Mm-hmm. Yeah. But so far, Europe and also the US are slightly lacking behind of what Australia has been doing for the last couple of decades. So Australia had very wide governmental funding to collect data throughout the whole country on hyperspectral drill core, but also map the whole Australian continent with hyperspectral airborne measurements, for example. So compared to what Australia has been doing, where we have like really clear hyperspectral maps of the surface and then of the subsurface based on all of these huge drill core archives on hyperspectral data, the US is now catching up with that on that scale, where we have the Earth MRI initiatives of collecting data across really huge areas on the, especially Western US. Mm-hmm. I think James can correct me on that one. But we do, from HySpecs, but also from my work before at the German Research Center for Geosciences, we see a lot of initiatives within the US that are predominantly academia-led or governmental-led to bring hyperspectral into all of these mining archives and make sure that the data can be available to miners outside of an academic perspective.
Sure. And I think in the U.S. in Wyoming, that Earth MRI is led by the State Geologic Survey. Is that right?
Correct. So the Earth MRI program is a U.S. Geological Survey program that works with each state geological survey to accomplish different tasks. Some of those tasks are led directly by the State Geological Survey, and other tasks are just simply facilitated by that geological survey. So there are campaigns right now to fly hyperspectral imaging across most of the southwest of the United States. Included in this is Wyoming. In the next 2 or 3 years, they plan to fly a small portion, southern strip along the southern border of Wyoming, using manned aircraft and providing hyperspectral data with a resolution between 10 to 15 meters per pixel.
Cool. And that maybe could be something we could use to, here at the School of Energy Resources, to go look even more closely with the drone, perhaps, if we see something interesting.
Yeah, absolutely. I mean, I think right now I know there's companies in Wyoming that are using satellite data, but the problem with satellite data is that you can get these false positives.
Yeah.
You're not really quite sure if the camera's seeing the correct things. So this manned aircraft hyperspectral data will help make things a little bit more clear, and then that can be further refined using drone-based remote sensing and hyperspectral imaging.
Cool. So how are we here at the School of Energy Resources implementing this technology, I mean, even now? And also just talk maybe about the kind of projects that are underway or in development.
Yeah, so the 3D Visualization Center at the School of Energy Resources recently stood up a GIS and remote sensing program. We acquired an NDAA-compliant heavy lift drone and a hyperspectral imaging spectrometer from Hyperspecs. This camera can see in the visual near infrared and shortwave infrared wavelength regions of the electromagnetic spectrum. It's a very versatile camera. This is a camera that can be put on a manned aircraft. It can be put on a drone. We have a very short summer field seasons here in Wyoming.
Yeah.
And so the nice thing about this camera is when we're not using it during the summer to conduct airborne surveys, we can actually put it in our lab and mount it to scan core and hand samples as well. So yeah, the past year, we've been standing up this program and we're getting our feet off the ground right now. We spent this summer figuring out best practices for data capture, data processing, as well as analysis. And we're currently actually constructing a darkroom here in the Energy Innovation Center to do laboratory measurements. So yeah, we're starting now just to meet with researchers internally here at SER, as well as the private industry, to start scoping out a variety of different projects in preparation for next summer's field season.
So that's why you need the dark room.
Yeah.
I just get the request. I did not. I thought it was for something else. Okay, fabulous. So is there anything that makes Wyoming kind of a particularly good place for conducting hyperspectral surveys?
Yeah, actually, Wyoming's actually a great place. You know, hyperspectral imaging can be used for vegetation analysis, but also looking at minerals and different rock lithologies. And the nice thing about here in Wyoming is we don't have a lot of vegetation. A lot of those rock surfaces are exposed, which is really ideal for surface mapping. Additionally, it's dry here, as Friedy knows. She was commenting about it this week, how dry it is, but dry environments are really good for hyperspectral imaging. So additionally, Wyoming, about half of the state is federally owned property, right? And that actually helps us because it's much easier for land access for us to get on different pieces of land and to do those surveys. And then, yeah, additionally, I mean, Wyoming is an energy state. We're energy focused. There is a big push for critical minerals right now across the United States, and particular in Wyoming. And this is a technology that can help facilitate exploration and mineral characterization.
That's so great. And I love that you all made something positive out of the fact that we can't grow anything. It's really dry here. It's not good for gardens, but it's good for finding our minerals, apparently. So, okay, James, well, are there any plans to integrate this technology into like a state level initiative or other university programs or partnerships with industry? Like, so what kind of collaborations do you think are going to be the most productive and what's on the horizon?
Yeah, so again, right now our focus is working with SER researchers. There's a lot of grant work that we can assist on, Department of Energy grants. There's the Core CM project, the Carbon Ore Critical Mineral Rare Earth project, which we plan to assist on. But we all are talking to different state entities and the private sector as well. We have interest from several mining companies right now to begin scoping out projects. I think where we stand is that we want to develop proof of concepts for industry. Maybe there's a company that is struggling with exploration and, you know, they're interested in hyperspectral imaging, but, you know, hyperspectral imaging is expensive and it's complicated. And so we hope to assist private industry in possibly doing proof of concepts and standing up programs. Maybe they invest a little bit money into this program. We can go show them how it's done. We can show that it's successful, and then we can facilitate them in possibly standing up their own program and making mining more efficient for them in the future.
It strikes me that it's very similar to what SER has done in other areas. So, for example, really surveying the state and doing a lot of research over the years for, let's say, carbon storage or oil and gas or, other materials, doing that pre-work and kind of us scouring the state to see what's out there. I think part of the objective there is just to get Wyoming a little bit ahead, to make investment here more attractive, and then maybe just get the attention of companies, or if they're already here, if they have land, make it easier for them to invest here, especially if they're looking at a portfolio of options. If we can help reduce uncertainty here, maybe investing here will be more attractive.
Yep.
So I think it's very in line with kind of how we're approaching a lot of different industries. So Freddie, let's go back to you. Can you talk just at a high level how hyperspectral imaging can support smart data-driven resource management? Could it help us cut down on regulations or red tape by maybe answering questions? And if so, what questions? And also, how could it help landowners, whether the landowner is industry or private landowners, or the state, or even the feds, make more informed decisions and kind of arrive in the best economic future for Wyoming?
Yeah,
that's a lot in that question.
That's a very big question. I try to split that up into sizable chunks. But so I think hyperspectral, first and foremost, will help you digitize some of the information that you already have digitized in geological mapping, but it can give you a little bit higher resolution and also enable more digital initiatives around specific areas in Wyoming or in general for geologists and miners. So it can be used as a decision aid for faster screening, but also to go back to projects, since we are kind of lucky that geology doesn't necessarily change in very fast timescales. Once you recorded an image or once you recorded a surface, we are quite secure in having that digital record for a little bit of time at least.
Yeah.
So that can be really useful to go back into the field, even though we are out of field season. A lot of the data can be used in digital twinning of exploration sites, but also in operational mining, which can be interesting to go through different timescales where we actually do see change made by the miners themselves and see these fresh surfaces and have a very clear record of change that cannot be mapped in that scale by any other method or in that actual time frame. For regulators or landowners, we see that it can help a lot with environmental stewardship as well. So either pre-mining or even while mining, or we have a lot of projects in post-mining as well, where hyperspectral can help map environmental condition studies to see how it changes pre-mining or during your operational mine.
So this goes way beyond topography.
It goes way beyond topography, yeah. We have a couple of EU-funded initiatives right now that we're working on where we're very interested in seeing not only land cover change, but mineralogical change that can tell us something about the reactivity of a surface. It can help you figure out if there's acid mine drainage developing quite early on. But it can also help us figure out when that stabilizes. So it's a really good mapping tool to figure out a lot of different things across the mining value chain and through the life of mine.
And you haven't, you're talking about it, but not said the word maybe is reclamation and maybe potentially understanding if there's changes in the soil that might be not helpful for reclamation, that you would be able to know before and after and maybe kind of address that in your reclamation process and make a more successful and more timely outcome. So.
Yeah, 100%. So it not only it can find these penalty minerals as well, where you would want to know which mineral might be causing harm to the environment or to the water discharge from that area. But we also see that it finds these deleterious minerals, which are minerals that will change recovery in operational mining. So it can help you figure out if and how you want to adjust your process or your blending in the mine to make sure that you get the most out of the material that you're mining, which then can also help you figure out when to discard waste, when to not spend energy or hauling gas to bring material into the processing change and instead already put it onto mine waste facilities without it needing any reagents and any other processing to recover minerals that aren't actually in that material. And so it's a really good tool to not only try to figure out if we have a deposit at hand in exploration, but in operational mining, to see if we are extracting the correct material and also bringing it to the correct places within a mine site.
Great. Okay, so you've both done a really good job kind of explaining the technology. I appreciate the crown analogy, and explaining how it's being used and the value and the positives. So James, on the flip side, can you talk about what might get in the way of us using this? Like what barriers, whether they're technical, financial, or regulatory, do you think could impact the use of hyperspectral imaging statewide? And is there anything specific with data processing or equipment costs or adoption by industry?
Yeah, I mean, in its simplest terms, hyperspectral imaging is an expensive and complicated technology. I think that's why mining companies are a little bit slow to adapt this technology. There's a lot going on. It's a cutting edge technology, and with that comes a large learning curve. Workflows aren't dialed in as much as other analytical methods, such as maybe XRD or XRF. There needs to be a little bit more standardization right now. Methods and approaches can vary from one camera manufacturer to another camera manufacturer. Additionally, flying large drones with really expensive, heavy cameras.
In the wind.
It's at really high elevations it's difficult. High elevations and wind are not ideal to fly these large drones with really expensive payloads in. So that's been definitely a task. It has an effect on the batteries. The drone has to work harder to stay aloft, drains the batteries quicker. So other issues. Hyperspectral imaging in remote sensing, there's two different types of sensors we could say. There's active sensors and passive sensors. An active sensor would be something like a LiDAR scanner that basically emits a laser, and then that laser bounces back and can be acquired and analyzed by the sensor. Hyperspectral imaging is a passive sensor, which means it doesn't emit energy. It actually just uses the sun's energy to be able to get that reflectance. And so if it's cloudy, if it's rainy, if there's wildfire smoke in the air, these are conditions that are not ideal for hyperspectral imaging. So we're really looking for those beautiful blue, sunny sky days to conduct these types of surveys. And I'll also say that hyperspectral imaging files and images are extremely huge data sets. We were out this summer collecting data sets, and a single data set can range from tens to hundreds of gigabytes. So it creates issues with storage, and you don't want to just throw things on the cloud because you also need access in quick environments for data processing and so on. So there's a storage issue which can be addressed, but it's a lot of data that's being collected. So.
You know what strikes me is certainly for smaller mining companies or those just doing initial exploration, or even maybe the big mining companies in the state, because this technology is new and all the things you just mentioned, it might not make sense for like one company to have their own drone, their own hyperspectral imaging technology and the equipment and have all that cloud storage and then have to hire someone. So I guess I'd just say thanks for kind of bringing this to us here at the School of Energy Resources, because maybe we can be working with all these industry partners and serving that need in the state and help adoption happen faster here than if our industry partners kind of had to do it on their own, right? Because they're always looking at costs, and that's a tough one maybe if they don't need it all the time and it's sitting there unused. So
and doing proof of concepts, I think, allows them to make an informed decision. Maybe they see a success story, but they also don't want to invest in it, and they continue to use our services. Or maybe they're interested in using other services. We're also in contact with a variety of service providers around the United States that are very efficient at scanning large amounts of core, so to speak. Or, if maybe they are interested and they see the success in this and they want to take that next step, and we can help facilitate putting them in touch with the right people and the right cameras and the right equipment to stand up their own program.
Nice. So can you talk about any pilot projects underway now in Wyoming that are at a level you can share with us, and what are those attempting to demonstrate or discover?
Sure. I can share with you two things. One, we recently submitted a proposal for an ArtStar grant in Wyoming, and that's a competitive funding opportunity at UW for transitional research projects with strong commercial potential. So we recently submitted a proposal for funding, and we are working with a uranium industry partner called DISA. And so the title of the project is Drone-Based Veneer Sweer Hyperspectral Imaging to Reduce False Positives in Legacy Uranium Waste Detection. And
that's a name.
And prioritize.
Oh, it's still going.
Feedstocks for DISA's HPS processing. So DISA does this high-pressure slurry ablation. It's a chemical-free mechanical process that uses high-pressure slurry jets to break down and liberate target minerals from ore or waste. So the idea is right now they are scanning these feedstock piles using satellite data.
Oh,
and
wow.
it's coarse, and they're getting a lot of false positives. And so we are basically put together a proof of concept to come in and do field spectroscopy as well as drone-based spectroscopy, and basically try to create a model for them to be able to prioritize their feedstocks in a more efficient manner.
Nice.
I'd also say that we're also exploring other avenues with a state agency. This is just a pilot program that we definitely want to explore. It's not mineral related, but we are in discussions with Wyoming Game and Fish right now using hyperspectral imaging for population species counts. So basically, game and fish struggles sometimes using airborne photogrammetry to basically do population counts. So the idea is, can we use hyperspectral imaging basically to differentiate between different types of species? Can hyperspectral imaging be used to differentiate between an elk, a moose, and a deer, and an antelope? And so the concept is, if we can develop this proof of concept, that we can put a camera on a manned aircraft, and hyperspectral imaging might be able to be used to basically do population counts. So it's something in the works. It's a pilot program, and something that we're slowly focusing on as time permits.
Are you doing that by their hair? Someone
Correct.
told me that. Okay.
Correct.
The differences in the hair. Okay. Wow, that's so cool. So yeah, there are obviously a lot of applications outside of energy and minerals. That's just our focus here at the School of Energy Resources. So Freddie, let's think big picture. Like, looking ahead, do you see hyperspectral imaging, where will it be in 5 to 10 years? Do you think it's going to be something that is relatively routine in terms of exploration and monitoring?
Yeah, so I've been in hyperspectral for the past 10 to 12 years already. And I think every year I do consider getting one step closer to it becoming a routine tool. I think the 5 to 10 year timeframe that you just mentioned is probably the more realistic one. But we do see hyperspectral become a more standardized tool. As James said, UAV, like the miniaturization of those instruments, is a quite recent thing. So the UAV technology and the standardization of those processes is at an entry level at best currently. We have a lot of initiatives with customers and also European funding to get it to a higher technical readiness level, or even an off-the-shelf solution. But we see that happening in the next 5 years, so that people can take the drone out and get a standardized mineral map out of it without having to go through that very steep learning curve that James mentioned before. For other applications in mining or energy resources, we do see a lot more standardization already, especially since we can control illumination in other environments. So we have cameras mounted over truck weighing stations to measure the truckload and the mineralization in the truckload. We have cameras mounted over conveyor belts to do real-time monitoring of quality of material. And we see that especially currently in the quarrying industry. So we see that for limestone quality and for potash quality and all of that. We have a lot more standardization going on there. So I feel in these areas, especially with cameras mounted over conveyors or over like stationary equipment or even at stationary stockpile monitoring sites, I feel like we are much closer to having a standardized tool that can be easily picked up just as any other standard tool in mining and then be integrated into the deposit modeling. So even though you've said several times this is pretty high resolution, and if you had it over a conveyor belt, that would be pretty high resolution, but it can still do the real-time feedback, and maybe if the quality wasn't sufficient, be enough to like inform the operators. Yeah, absolutely. So we have both sorting and non-sorting setups already, which means that if we have a non-sorting, just a monitoring tool over a conveyor, it will automatically monitor quality of the feed and then will flag when that falls outside of a specific threshold. But we do also have projects where we are, for example, sorting refractory bricks from steel, from the steel industry, from steel casting ladles, right? Or the cement rotary kiln industry. These refractory bricks that we have in cement rotary kilns, for example, these need to be really heat resistant. They have to withstand 1,500 degrees Celsius, for example. In order to produce these bricks, you need material that produces a lot of CO2 in the production itself. So we are currently working with a big company in refractory materials to sort out these bricks that have been broken out of these instruments or out of these rotary kilns, for example, and make sure that we can classify the quality of those bricks and make sure that the highest quality brick from the recycling goes back into the stream for primary raw materials as well. So it really helps us to figure out quality, and it helps us to do that in real time. And for these sorting mechanisms, we are able to actually eject the material because the cameras can work at that speed.
Cool. Another incredible application. So James, what kind of opportunities does hyperspectral imaging open up for students here at the University of Wyoming or across the state? And are there any research projects or internships or career paths emerging in this space? And also, how can students find out about this?
Yeah, so most universities across the United States have some sort of remote sensing programs or classes that kind of give an introduction to remote sensing. But there are very few entities in the U.S. right now that are introducing hyperspectral imaging into their curriculum. Two universities that come to mind are the Colorado School of Mines and the University of Arizona. They are introducing hyperspectral imaging. Students are doing thesis and dissertation work surrounded by hyperspectral imaging. So yeah, we do have some remote sensing classes here at the University of Wyoming, but we hope that once we get everything up and running and finalized, that we can start doing some of our own classes on hyperspectral. We are going to be looking next summer for a couple students to assist us with drone campaigns in the field, as well as core scanning in the lab. So I think shortly after the new year, we'll start advertising these positions. We're also working on funding opportunities with the Department of Geology for master's students that are interested in using these technologies as well. So there'll be more and more opportunities for students at the University of Wyoming in the next year or two.
That's so great. And that's so cutting edge. And I'm excited that we have the opportunity to make this available to our students. It's cutting edge. People come here to do geology, and it's cool that we're staying on the cutting edge. Well, that brings us almost to the end of this interview. So thank you guys so much for talking about such a cool technology and its application really globally, but also here in Wyoming. And thanks for all the hard work you're doing on this. And we always close our interviews asking a question that celebrates kind of the state of Wyoming and why we're lucky to be here. And James, you mentioned those blue sky days, which we're having on the day that we record this. We don't always have them, but we get them a lot. So for our last question, we'll ask both of you. Freddie, I don't know how many times have you been to Wyoming? Is this it?
It's my first time. Yeah.
Okay. So usually I ask, what's your favorite place to be in Wyoming? But I'm guessing this is the only place you've ever been.
Yeah.
So maybe you can just say your first experience here.
I've had a really good experience so far. No, we've had a couple of days working in the lab together. I've met a couple of people, but I really liked the open-mindedness and the enthusiasm that I've felt so far. And apart from that, we have a beautiful autumn day.
Yeah,
so I have zero complaints. It's been a really good experience.
Well, we're glad you're here and really appreciate the opportunity to host you. James, you don't get off so easy. You're here in Wyoming. You're here in Laramie. So for you, your question is, what is your favorite place to be in Wyoming?
Yeah, so I would have to say I'm an advocate of Southwest Wyoming, in particular the Flaming Gorge area. And I think I love that area a lot just because when I was an undergrad and spending my first days at a geology field camp, it was the Flaming Gorge area that I woke up and did my first mapping exercises. And now, almost a decade later, I return to this area and am working on a PhD using hyperspectral and drone technologies to lithologically map. So the Flaming Gorge area is a beautiful area, a remarkable region, and a place that I hold close to my heart.
Cool. Well, thank you both so much for doing this podcast, and thanks for all you do. And Freddie, thanks for visiting us here. And James, thanks for leading this effort and kind of taking a leadership role in bringing this technology to the School of Energy Resources so it can benefit the state and our energy and minerals producers.
Wonderful. Thanks for having us.
Thank you so much.
Thank you for listening to this episode of Energy Frontier, the Wyoming Landscape, the podcast that highlights the School of Energy Resources at the University of Wyoming. You can expect a new episode of Energy Frontier every other Wednesday on Apple Podcasts, Spotify, or wherever you listen to podcasts. See you next time.